So at the end, my link 2 multiplied by CR will give me the half-life. So what is link 2? Link 2 is equal to 0.693. Okay, so I can now have half-life of charging on the charge of a capacitor is equal to 0.693, then the time constant, the bond of the capacitor and the resistance. That's how to determine the half-life of that. Okay, half-life of charging and discharging of the capacitor. Don't forget that I said that the half-life of charging or discharging of the capacitor is the time required for the charging of the capacitor to attain exactly half of the initial charge. If that is gotten, let us move to the energy. We have got energy stored in the capacitor. So let us look at the conservation of energy in capacitor. So when you are talking about the conservation of energy in the capacitor, quickly, what do we mean by the conservation of energy in the capacitor? So there are two things you have, all right? You have your capacitor before connection and capacitor after connection. So we are going to use the conservation of energy to relate the two together, okay? So we have what before connection is equal to after connection, all right? Then you are going to find what happens in before connection and what happens after connection. It's like a momentum, all right, where you have before collision and after collision. So the conservation of energy between two capacitors connected to each other, conservation of energy between two capacitors connected to each other. Let me write it here. We have conservation of energy, between two capacitors connected to each other. Alright, so let's look at that. Now, I said your before connection is equal to after connection. Alright, so let's look at before connection of the capacitor and after connection. So we have before connection is equal to after connection using the law of what? Law of conservation of energy. The law of conservation of energy says that energy cannot be created nor destroyed, but it can be transformed from one form to another form. Okay, if that's the case, so before connection we have charge, all right? So your before connection, your port before connection is equal to after connection. So your before connection is Q, all right? After connection is also what? Q. So we find it. So to find before connection and after connection, what's going to happen is that we are going to be having two values, all right? So Q and Q. So you have your kinetic energy for that, all right, just like kinetic before collision and after collision. So what's going to be KE? KE for before connection, if my Q is equal to CV, it's now going to be K is equal to 1 over 2 CV squared, all right? So that's the KE, kinetic energy before collision. Then KE after collision is also going to have, or after connection in the context, is also going to have the value. So for my before connection, I'm going to be kinetic energy before connection is going to be 1 over 2, all right? You know your Q. Alright, we're having KEQ. So you have 1 over 2 CV squared plus this one is 1 C1V1 squared plus 1 over 2 C2V2 squared. This before connection. If you have to find the kinetic energy before connection in the capacitor, use 1 over 2 C1V1 squared plus 1 over 2 C2V2 squared. But if you are looking for after connection is going to give you 1 over 2 because your potential is going to be the same. 1 over 2 C1V squared plus 1 over 2 C2V squared. Alright. So what is common? V is common to the both sides. So I'm going to be having V or 1 over 2 V squared, open bracket, what? C1 plus what? Plus C2. This after connection. Well, this one is what? Is before connection. So if you find the common voltage together at the end of the day, your voltage is going to give you a value of C1V1 squared plus C2V2 squared over C1 plus C2. So if you have to determine, all right, the voltage, okay, the voltage, use that value, the common voltage. You have we have C1V1 squared plus C2V2 squared over C1 plus V plus C2. That's going to be our common voltage. So let me write it out. So if you equate BC is equal to AC, at the end we are going to be having, all right, our AC, our BC, kinetic energy before connection is equal to kinetic energy after connection. So we have our common denominator to be C1 V squared, that is C1 squared plus C2 V2 squared over C1 plus C2. Alright, this is what we're going to have at the end of the day. Alright, for the common potential. Now, what is going to be the kinetic energy before connection? Kinetic energy before connection, alright, kinetic energy before connection is going to be, what we have here, we have 1 over 2 C1 squared. So if you have to determine it right, K is equal to 1 over 2 C1 V1 square plus 1 over 2 C2 V2 square. Okay? Then if you are to determine the kinetic energy after connection, Ke after connection, you are going to be having 1 over 2 V square, open bracket, what? C1 plus what? C2, as earlier stated. This Ke before connection and this Ke after what? Ke after connection. Alright? 1 over 2 V square, open bracket, C1 plus C2. So, then the next part, if you are looking for the loss energy in the connection, you have loss energy is equal to your Ke before connection minus after connection will give us the energy lost. Alright? Ke before connection minus Ke after connection will give us the energy lost in the what? In the capacitor. So that is all, alright, that can be asked of when you are talking about the context of capacitance. Okay? Don't forget that I said your loss energy, you have to subtract your what? Your before connection minus after connection. It will give you the loss energy in the what? In the capacitor, or we call it energy loss. Energy loss. So take note of that and do well to attempt your questions quite very well if you come across any of those things in the examination. So I hope that you find that helpful. All right, take note of those concepts on the board, and God bless you. All right, please, if you do have any question, do well to send it to me. All right, I'll attend to them quite important. All right, I'll attend to them. Send it to me as a screenshot. All right, on WhatsApp. I'll attend to that. God bless you.